Alright, notes 3.6, angles in polygons. So a blank is one which no part of a line segment connecting any two points on a polygon is outside the polygon. So that's a convex polygon. So a convex polygon is one which no part, so the line is always inside. So wherever we connect these points, it's always inside. Whereas a concave polygon is one which a line segment is outside, so we can connect parts of a polygon from the outside. For our purposes, when we discuss a polygon, we're going to assume we're talking about a convex polygon, unless we state otherwise. So now, we're going to fill in this chart here to figure out the sum of the measures of our interior angles. So if we have a triangle, the number of sides, it has 3 sides. Triangle has 1 triangular region. The sum of all the interior angles, it's 180 degrees. If the polygon is regular, then the measure of each interior angle is going to be 60 degrees. Now if we look at a quadrilateral, well, has 4 sides, has 1, 2 triangular regions, well, 180 degrees and 180 degrees, it's 360 degrees. And if it's regular, well, we know that each interior angle is going to be 90 degrees. A pentagon has 1, 2, 3 triangular regions. So a pentagon has 5 sides, has 3 triangular regions. So we have 180, 180, and 180. So that's 520 degrees, 540 degrees. And if each polygon is regular, then each interior angle is going to be 108 degrees. Then we look at a hexagon. Well, a hexagon has 6 sides. 1, 2, so it has 1, 2, 3, 4 triangular regions. So it has 4 triangular regions. So it's 720 degrees. And if the polygon is regular, each angle is 120 degrees. An octagon, well, an octagon has 8 sides. And an octagon has 1, 2, 3. So 1, 2, 3, 4, 5, 6. Not this last one. So it has 6. So an octagon has 6 triangular regions. So if each one's 180, so we get 1080. And then the measure of each angle is going to be 135 degrees. So what we're saying is an n-gon, the number of sides an n-gon has, it's going to have n sides. Now if you notice each one of these, well, what are we doing here to figure out the number of triangular regions? Well, we're subtracting 2, so it's n minus 2, so to get the triangular regions. Now the measure of the sides, well, we go from 180, so what we're doing is timesing this number, so 1 times 180, 2 times 180, 3 times 180, and so on and so forth. So we want to do 180 times n minus 2. So that will give us the sum of the measures of all the interior angles. So the sum of the measures of each of the interior angles of a polygon with n sides is 180 times n minus 2. And now to find if the polygon is regular, well, what we do is you divide this by how many sides there. So this is divided by 3, divided by 4, divided by 5, divided by 6, divided by 8, well, divided by n. So this is going to be 180 times n minus 2 divided by n, and that will give us each interior angle of the polygon with n sides. So now if we look at this, right, so interior angles are inside, the exterior angles are the ones on the outside. Now if we take a look at these and we put these together, what we're really forming here are we're going to be forming circles. So whenever we put all of our the measure of all the angles together, whoops, it's going to just form a big circle. So whenever we bring these in, it just forms us a big circle here. So what we need to know is that the measure of all of these angles together is going to be 360 degrees, because it's going to be going around this. So it's going to be 360 degrees. It's a little hard to see with these. I know this looks like a triangle here. But when we put all of our angles together, because if we bring all these inside, it's going to give us 360 degrees with all of these shapes. So we're going to be forming circles here when we bring all of these angles down together. So what we want is that each of these, what we need to know is that if a triangle has 3 sides, the sum of the measures of all exterior angles is always 360 degrees. Because we bring all those angles inside together and it just forms a circle around. If the polygon is regular, then the measure of each exterior angle, so we divide by 3, so 360 divided by 3 gives us 120 degrees. And then once again, if we look at a triangle here, if this is regular, we know that each of these is 60 degrees. Well, the outside has to be 120. 120, 120. Alright? And then if we look at a quadrilateral, it has 4 sides. The sum of all the measures of the exterior angles is 360 degrees. We divide that by 4, and we get 90. A pentagon has 5 sides. Well, it's 360 degrees, and we divide that by 5, and we get 72 degrees. If we look at a pentagon, so here's the pentagon. We said that each interior angle of a pentagon, or each exterior, is 72. And if we look at all the interior angles, I forget. A pentagon, 108. So if a pentagon's 108 degrees, well, the exterior angle has to be 72 degrees. So if it's 108 for the interior, the exterior is 72 degrees. Hexagon has 6, so we have 360. We divide that by 6. Each exterior angle is 60 degrees. An octagon has 8, so we have 360. We divide that by 8. We get 45 degrees. An n-gon, alright, so number of sides is n. So the sum of the measures of all of them is always 360 degrees. We divide it by n, so we get 360 divided by n. So the sum of the measures of the exterior angles is 360 degrees, and each exterior angle is 360 degrees divided by n. Now if we practice, find that indicated angle measures, well, we know that this 4 sides, so 180 times n minus 2 divided by n, 4 sides, 180 times 4 minus 2 divided by 4, that's going to give us 360. So we know that this shape will add up to be 360 degrees. You should also know that it's a quadrilateral, which is 360. So we do 360 minus 90 minus 75 minus 85, and that will give us minus 75 minus 85, 110 degrees. We know that we have a triangle. We know that each exterior angle in a triangle, when we add them all together, is going to be 360 degrees. So minus 132 minus 120. So 360 minus 132 minus 120. This is 108 degrees. A pentagon has 5 sides. So our formula, we have 180 times n minus 2 divided by n. Notice I'm writing my formula down every single time. So 180 times 5 minus 2 divided by 5. So we have 180 times 3 divided by 5. So we get 108 degrees. Or actually, scratch that. I don't want to divide by n. That's the measure if it's a regular. This is not a regular pentagon. So 180 times n minus 2. So 180 times 5 minus 2. So 180 times 3. That gives us 540 degrees. So pentagon is 540. So now we subtract all of these. So we do 540 minus 130 minus 100 minus 110 and minus 90. So 130 minus 100 minus, and we get 110. So the question mark, that missing side is 110. We have a triangle. So a triangle is 180 degrees. We know that one side is 90, so we're left with 90. Both of them are congruent, divided by 2. They're each 45. We could have that in our head. We should have known that one, but we can use a formula to figure it out. So this angle and this angle are congruent, so this is 100. This angle and this angle are congruent, so this is 110. Pentagon, we know it's 100 times n minus 2. Pentagon has 5 sides. That's 5 minus 2. So this is going to be 540 degrees. And we know that this is 420. So 540 minus 420 is 120 degrees. The last one, we need to figure out this one right here. So we can simply say that, well, 75, this is 180 degrees, so 180 degrees minus 75 is 105. These two are congruent, so the question mark is 105 degrees. We could also say 360. We have two, and we know that this is 75 degrees, so we could have subtracted all of them and figured it out. The next step, if each polygon, in each example, an interior angle measure of a regular polygon is given, find the number of sides. So if we have 140 degrees, now this is why I was writing the formula down each time. So if the interior angle is 140 degrees, we want to know how many sides. So our formula, 180 times n minus 2 divided by n equals 140 degrees. Now we need to use some algebra to solve this, so we multiply both sides by n. So we have 180 n minus 360 equals 140 n. So we distributed, multiply both sides by n. We subtract 140, or we can subtract 180 actually, minus 180. I will write this over here. So I have negative 360 equals negative 40n divided by negative 40. They cross off, and 9 is equal to n. So if it's 140 degrees, it has 9 sides. Now if it's 150 degrees, we use the same formula. So I'm going to write it right up here. So we have 180 times n minus 2 divided by n equals 150. We distribute and multiply both sides by n, so they cross off. So now I have 180n minus 360 equals 150n. Subtract 180. So negative 360 equals negative 30n. Divide by negative 30. And 12 is equal to n. So if it's 150 degrees, it has 12 sides. 156, same formula. So we do 180 times n minus 2 divided by n equals 156. Multiply both sides by n. Distribute. So I have 180 n minus 360 equals 156n. Subtract 180. So that will give me 24. Negative 24n. Divide by negative 24. So 360 divided by 20, or negative 360 divided by negative 24 is 15. So this has 15 sides. Notice I use the formula each time for these. So I got myself used to writing the formula down because I'm going to need to know the formula and how to use and solve the formula. And that is 3.6, our angles in Polygon.